Question 9. Now I think the key thing to notice here is that we do not have constant acceleration. Okay, this is not a SUVAT question like earlier on. We need to move between the formulas by integration and differentiation. Okay, because you can see acceleration is dependent on the time. Alright, it is not a constant acceleration. So find the velocity after 5 seconds. So you've got to remember that the rate of change of velocity, if we differentiate velocity we get acceleration. Working the other way, if we integrate acceleration we get velocity. So in order to work out velocity, a formula for velocity, we need to integrate this acceleration formula with respect to t. So integrating this, we get 4t minus 0.2t squared over 2, which simplifies to 4t minus 0.1 t squared. So that's a formula for velocity which we can use. We've been asked to find the velocity after 5 seconds, so that's when t is 5. So substituting 5 in, we get v being 17.5. Now for part 2, we're being asked what is happening to the velocity at t equals 20. Now substitute this 20 into the acceleration formula, and you'll see when t is 20, our acceleration is 0. Okay, so look, we've been accelerating and accelerating and accelerating all the way through. Well, we've been decelerating, we're slowing down. Okay, so but by the 20th second, our acceleration has actually got to 0. Okay, so so we've reached our maximum speed. From then onwards, we're no longer accelerating, we're actually decelerating. So at a equals 0, we've reached our maximum velocity. Okay, so we are continuing to accelerate over the first 20 seconds, but once we get to 20, our acceleration is 0. So from then onwards, we're decelerating, we're slowing down. So our answer needs to be after 20 seconds, our acceleration is 0, maximum velocity. Now part 3, find the distance travelled in the first 20 seconds. Distance travelled. Now the rate of change of distance is velocity. So you would differentiate a distance to get velocity, and going the other way you can integrate velocity to get distance. So if we take our velocity formula here and we integrate again, we get a formula for distance which is this, which simplifies to this. So substituting in when t is 20, we get our distance being 1600 over 3, or 533 1/3 meters.